So students, we have seen various properties of sound wave. So here is the last property, that is wavelength of sound wave. Okay, as we have already discussed about it, like the wavelength is the length of the complete oscillation. Here, supposingly, it is drawn for a particle, one particle that is vibrating at its mean position. So how we can draw a graph for it. Okay, so this is the way we can draw the graph, and here we can see that the density is shown by y-axis and this is the x-axis, in which we can take the time period. Okay, so now as you have seen here, what is wavelength? Wavelength is complete one oscillation, indicating complete one oscillation. Okay, like supposingly it is starting from here and going to the highest peak, that is the maximum displacement from its mean position, then back to the mean position, and again from here to next opposite extreme position, and then back to the mean position. So this is one complete oscillation. So in this diagram we can take what is the wavelength, is the length from here to here. So the distance that has been covered here from here to here is the length, wavelength. Okay, so even you can take like this. Like suppose this is one wave. Okay, so this is the length of the one wave, so one wavelength. Okay, so here what we have seen, that the topmost part of the displacement of a particle from its mean position in a positive direction, so we will call it as the crest. And again this is the negative part. Okay, why we are calling it negative? Just because it is going in opposite direction to the other one, and it is known as trough. Okay, so here if the wavelength is like this, so we can see that continuously it is having one crest, two crest, three crest, and this is going on in that manner. Okay, so from crest to crest again we will see that it is equal to the distance that we have taken as the wavelength. How? See here what is happening, one complete this oblique, okay, and this the below part here, जो ये पूरा ऊपर diagram बना हुआ है on above the x-axis is similar to the below diagram, that is below the x-axis, and if we have taken it together, so we will see that it is complete one thing. So from one crest to another crest, now you can see that this is half of the above crest, this is half of the below above crest, so half and half together will make one, and this is one complete below trough. So again one half means one, that is this part, and below जो नीचे वाला part है, that is this one. So again we can see here from here, so the mid part of the crest, like from one crest to the another crest, it is equivalent to this thing. Similarly, even you can take one trough to another trough, again this will going to be one wavelength. So this is how wavelength can be measured, and it is going to be measured in the Armstrong. Armstrong is what? It is 10 to the power minus 10 meters. Okay, meter is a big value, and you know that for a standard measuring of length, we take length as a meter unit. Okay, but these wavelengths are very small in size that even we cannot see it through our naked eyes. So how we are going to measure that? Okay, so we are just keeping in record the vibration part. So feeling that vibration, and some instrument parts are there that is denoting that the wavelength of a particular wave could be this much of length, and that is if we are taking 10 to the power minus 10, that is denoted as the Armstrong part. Okay, so Armstrong is 10 to the power minus 10 meter, that means 1 meter का भी इतना छोटा part है ये, that is Armstrong, 10th equal part. Okay, now the symbol for the wavelength is this one, lambda. Lambda is the symbol, and this is going to be shown that the wavelength of the sound wave, if it is written lambda is equals to this and this, so you can predict that yeah, this is the wavelength of a sound wave.